Science tells us that the human body generates about 11 million bits of information per second. Human brains are capable of processing about 50 to 60 bits per second. When translated to computing measures, the human brain can perform at most about 1,000 basic operations per second, or 10 million times slower than the computer. It does not seem possible that we should be able to function on 50 bits a second, let alone produce great works of art, literature, and science. One possible answer to our ability to process and react accordingly to that information is found in the notion of delegating authority. Subsystems process and analyze the bulk of data generated by human bodies without conscious involvement. Only relevant, actionable information rises to our attention. F5's Office of the CTO wrote a book, Enterprise Architecture for Digital Business. I interviewed the authors of each chapter. For Chapter 6, I spoke with Michael Wiley, Vice President and CTO of Applications at F5. We explored how these data processing concepts translate to digital business. Whether the responsibility for processing, analyzing, or even acting on data generated by the myriad of systems that comprise the business is delegated to the appropriate subsystems, only those events requiring human attention should rise to the surface, and thus establish an environment in which digital business can scale without commensurate numbers of people to manage it. Chapter 6 explores the explosive growth of telemetry and the convergence of IT and OT data to enable observability and ultimately autonomic operations. I hope you enjoy this conversation. Hey everyone, I am joined by Michael Wiley, and he is our VP and CTO of applications here at F5, and he's actually the author of one of the chapters of the book, Enterprise Architecture for Digital Business. Specifically, his chapter is on telemetry and observability, so we're going to have a bit of a discussion around that. And so I'll start off by saying, as far as data, what's so special about telemetry specifically when it comes to data?
It's a broad topic for sure. But telemetry is the premise and basis on which we pretty much get all the insights and information off of any particular product, software, service, or application. So it is something that most people are very familiar with when they think of IoT devices. All the information. Think about your Nest home device. It has all your temperatures in there. It emits this time series data where you have a timestamp, a metric of some sorts, and you can track that and train that over time. So we're in a data-driven world. So we have to make these business decisions based upon that data. So every device by the default now emits some level of telemetry from your car to your home devices to network equipment, our load balancers, our software, our clouds. All of this data is kind of somewhat, comprised of what we would call telemetry.
And then another word that's used inside of this chapter as well is observability. How would you differ that from just visibility then?
So it's again an interesting word, and it's kind of been more predominant over the last few years. When you think of where your applications are in, say, public clouds, hybrid clouds, on-prem, you're using different types of deployment models such as VMware or Kubernetes. You start to look at all these things as part of a system. And when you look at a system, even though all of these components within the system emit this data, which we would call telemetry, you need to be able to step back a little bit higher and see all this data in an aggregate way. And that's where you start to bring in this concept of observability. So not just one component of the system is visible or emits telemetry, and that might be in a very siloed way, say my application, or my Kubernetes infrastructure, which is in a public cloud or on-prem. You need to see all of this together in order to treat the system correctly, because systems have variableness, they change over time. Just making changes within a system shifts the system, right? So observability is about taking a broader system view of all of the components within the system.
And then kind of building on top of that then is one of the concepts touched on in the chapter is around observability and automation going together. So where do we draw the connection there?
Yeah, so I kind of look at it a little bit if you take a Tesla approach to it, right? An electric car, imagine all the data that's happening inside the vehicle. from the camera sensors and information that's being passed through the systems within the vehicle, ultimately to tell the brake system to press the brake when they see a child walking across the road, right? So that's the automation piece of it. When you now take it to an application level thinking, I've got all these users, millions of users coming in, accessing my application, doing certain activities within my application, but all of a sudden an infrastructure component is failing. And we're either dropping those requests or those requests are non performant. Now, what do I do? Well, I have to now automate those actions. Today, we're having humans pay attention to all that data. So, could you imagine a human being paying attention to millions of data inputs, right, and trying to actually physically, manually go shift the application to preserve a shopping cart, for instance, right? So we need this level of automation within our system, within the applications and the services in order to achieve our goals. So observability gives us the view of a whole system. The automation preserves the user experience, application performance.
And then one of the topics that keeps coming up throughout the different chapters of the book is form follows function. And we've seen through a couple of the other conversations that I've had is that, and this book is really meant for a lot of the C-suite, CIO types and director types to be looking at and evaluating changes that they need to make to their business. And so changes within an IT organization now, and you mentioned as well, like humans incapable of being able to process this amount of data. What kind of what kind of changes do you see happening to an IT organization now as they adopt observability and automation?
Yeah, but there's been a lot of changes to date, actually, that are positive and in a general direction that's good, optimizing the IT organizations. So everybody went out and said we need all the data, so they're collecting all of this data. Now they have a mass amount of data. Now, how do we consume it? And so they've hired automation teams to sift through that data, or data science teams to start building better insights or richer insights from that data. They've shifted their operational teams to pay attention to higher fidelity signals versus a lot of the noise. So, you do see some activities happening there. I think over time, you'll continue to see those things mature a lot more. In the past, industry tried to call this things like AI ops. Graduating it forward, you really want to pay attention to the business metric. What is the business metric that you're trying to achieve? That might be, I want 99.9% of all shopping carts to be successful, and so that, or I only want to lose $100 a day or $1,000 every transaction, or I'm willing to only lose that. So when you start driving those particular metrics, and I think that's what IT organizations and the C-suite will want to evolve, is get closer and closer to their business metrics. Then you can start making choices on the investments you make in the products and technology you choose, the cloud you deploy into, the amount of data you pay attention to. All of that will help you support the larger business metric challenge, right?
That's great insight. Thank you very much for your time today, Michael. It was great to go over this chapter with you. For anybody who's listening to this or watching this right now, we do have this book released, and it has a little link down below in either description or wherever you're viewing this video from. Should have a link in order to go and grab this book. So thank you very much, Michael, for joining me today.
Thank you, Boo. Have a good day.